So from fashion emergencies to real life emergencies, our second keynote would like to present to you is Bart van Leeuwen. I hope I'm saying that correctly.
It's pretty good.
He's a
it's horrible for international.
Dutch and German is not too far apart.
Exactly.
So yes, so you are a software engineer, but you're also a firefighter of, I think, 20 or 30 years. And so you know the link between smart data and actually saving lives. And we're very interested in hearing about that from you today. Thank you very much.
Vielen Dank. Auch ich rede Deutsch. Ich verstehe sogar das Schweizerdeutsch ziemlich gut. Aber die Vortrag wird auch in Englisch sein. Aber wenn da Fragen sind, nachher kein Problem. When there is another keynote speaker in front of you who has data engineers on their slide and is going to explain about knowledge graph, then you're struck with fear. I hope our explanation is going to be the same. And luckily, it is absolutely the same. It actually buys me a bit of time because I can click to a couple of slides a lot faster because, well, Katrina already took care of that. My name is Bart van Leeuwen. You can follow me on Twitter. And if you can see it on my Twitter handle, I do something with semantic technology, and I have something with fire. I'm here on behalf of my company. I own Netage, and we do smart data for smarter firefighters. And we coined the term smart data because we didn't want to sort of stuck ourselves to a specific technology, not linked data for smarter firefighters or big data, or I'm just going to say the word Adrian, blockchain for firefighters. That's an inside joke. We sort of try to do smart stuff for firefighters. The company exists for almost 25 years, and on the last 14 years, we focused primarily on fire services, and we do that on a global scale. And we operate on the edge of engineering and research, and that is exactly what Katarina was explaining as well. There is a whole lot of academic views on how ontology should be developed, and there you have the practical use on actually putting it into practice. That's what we try to do. So we're going to be friends on that subject. My relation to academia is that I'm a guest researcher at the Vrije Universiteit of Amsterdam on the Knowledge and Media group, and that group is specifically interested, how do you transfer something that is digitally stored to humans and vice versa? Because as Katrina, thank you so much for your slide, really thoroughly explained that humans and computers operate differently. So that is what we do at the VU research group. And as mentioned, I'm also a career firefighter in the Amsterdam Fire Department, and you can see me on the lower right corner, being prepared to do my job. So if you take a business, a university, and my firefighter job, yes, I'm a busy man, how do you combine that? It's my fear. I'm afraid. And that might sound strange because firefighters are supposed to be fearless and heroic people, and here stands one who is afraid. I'm afraid that something will happen to me, either one of my colleagues, or the people we serve, and that in the hindsight, we would figure out that all the data needed to prevent this accident from happening was actually known in our own organization or organizations we work together with. And I came across this fear about 12 years ago. When the open data came out, I was like, oh, there's a lot of data about the environment I work in, about the city I work in. Why aren't we using this? So I went to the board of commanders of the city of, for the fire department of Amsterdam, and I asked, like, can I explain you something? And then I had to explain this data problem to people who were not writing their own emails at that time. Can you imagine that? Trying to explain a data problem to people, say if they need an email, they ask their assistant to write it. I wasn't booed away, but people were like, well, we actually have no clue. One of the senior officers came to me, he said, don't be afraid, be assured that there will be places you go to, and we know you should not do certain actions, but we have no means of telling it to you yet. So if you have a wild idea, just go ahead. So I did. And I started it. You can see it on the date. This is the first production system I've created based on semantic web technology on linked data, or knowledge graph, as we call it nowadays. And it's from the 5th of December, 2009. So we're on this that long. And you can see in the color of my hair that, you know, it took quite an effort to get to the point where we are right now. So when I joined the fire department 20 years ago at the Fire Academy, there was no talk about data, obviously, but there was one interesting remark. And the thing I've learned there is they said, you're going to learn throughout the rest of your career. Don't think that if you come from the academy that you are a good firefighter. You can operate safely, but you're not a good firefighter. Go to your fire station of your assignment and suck up the knowledge. Everything they say, suck it up, because you're going to need it throughout your career. And keep doing that. It's like, okay, that makes sense. So I got my first assignment on this beautiful old fire station in the city of Amsterdam. Unfortunately, it's decommissioned, so we had cutbacks as well. The building is still there, but not a fire station. And that was my team 17 years ago. And one of the old guys at my fire station told me, Bart, we never have fire at normal people. I was like, okay, that's an interesting statement. That's an interesting piece of knowledge. You have to understand that I'm born and raised in the city of Amsterdam. We have 160 nationalities. Every major religion and all the side paths are being practiced in our city. Every sexual preference and gender identity is present and actively practiced, including all the fetishes. And every type of drug mankind ever came up with is being either produced, used in large quantities in our city. So my spectrum of normal is like huge. And this guy telling me we're talking about people who are beyond that spectrum. It's like, okay, I had no idea. I did find out, and I get back to the anecdotes a bit later. And there's a lot of stuff I can only do offline from what I've experienced. When I started looking and sucking up all this knowledge, but because there was so much more interesting stuff they were telling me. But then you have to realize that we work under time pressure. So in the 4 minutes, Amsterdam Fire Departments have 4 minutes response time. In the 4 minutes we have to get to the scene, there's a lot of stuff we need to think about. There's a lot of knowledge we have to use to make our work safe. And do you really think that we have a lot of time to think about all these things and even data when we know that this is the next thing we're going to face? So you see me here in a pretty standard house fire from Amsterdam perspective, where we were making our way in, and we were able to save a father and his 3-year-old daughter from the back of the house. But the house was a total loss. The thing is, this is a relatively standard fire for us, so we know what to do, we know how to operate, and we got it out in a couple of minutes. So if you go to these fires, what are your information sources? What are the sources of information you can use? And there it gets interesting, because this is the high-tech workplace of a commander in the Amsterdam Fire Department. It's the front right seat of the fire trucks. And if you look closely, you'll see a ton of information sources out there. I highlighted them, and I have to admit, we don't have the Nokia anymore, but it's not a smartphone. And the reason we don't have smartphones is they need to be ruggedized and they need to last forever, battery-wise. You just don't want to have a smartphone which batteries runs out really quickly. The more important thing is that if you look at all the user interfaces, you notice there is no similarity in them at all. And more specifically, most of the times, if you find a piece of information on one part, you need to sort of manually put it into the other system, which makes it really, well, unusable mostly. And there's books, there's tons of books. So we have the Anne Frank House in Amsterdam, which is a famous one. There's 5 pages describing the Anne Frank House. It's all in Dutch, so don't bother trying to digest it. For me, as a firefighter, the upper right corner in red is the only thing that's really interesting, because that is what the biggest dangers are. But now comes the interesting part. I know, oh, there's a reference there which actually is pointing to another book in the fire truck on operational procedures. The Anne Frank House is a very interesting location, because the fire station who's responding to the Anne Frank House has an average arrival time of 58 seconds. So from the time they roll out, within 40 seconds, till they're on scene is 58 seconds. You have to get your gear on, helmet on, gloves on. There's no time to actually go through data. So yes, we have all the information. Practically, we barely ever use it because we don't have the time to actually do it. And there is so much in there, how are you going to digest that? And if you start looking at connections and information, what is out there, what is usable for the fire service, it gets very depressing. Signs which tell you how many cars are parked. And what's interesting for the fire service in that? Well, if you have a garage which is completely full of cars, and now with the electrical cars that get up in flames really often, it's really important to understand how many cars there are actually in the garage. Currently, we have no idea. We only see these signs, and then you have to do the calculation manually. Like, okay, it has a permit. The top one has a permit for 1,000 cars, 342 free spots. It's packed. Oh, no, it has a permit for 400 cars. Oh, it's completely empty. Changes your operational perspective for this parking garage completely. Now, since this information is available digitally, why don't we use it? This slide is in my presentation for 10 years now, and we still do not use it. And if you look at it, there I saw on slide, I saw IoT. Buildings start talking to the fire service, and we're not listening because we have no idea how to sort of suck up all this information, ingest it. And the thing is that we are always chased by reality. The reality of our day-to-day operations always is more grim and more brutal than we ever thought of when we started to make the plans we actually give firefighters. This is a very tragic example. Everybody knows what this is? It's Grenfell Tower, right? 2 years ago. The tragic part of Grenfell Tower is actually that the fire department, 6 months before this happened, said the cladding on this building might be influential on how the fire behaves. Nobody ever thought that it would be this catastrophic. So people were aware that, well, we have a bit of information which could tell us something, but we have no means of actually putting it to practice. And when the fire broke out, well, the tragic results we've all seen on television. The inquiry is still ongoing. And, well, why didn't you use the information? Well, it's on hindsight, and there is I love South Park, there's a brilliant episode of Captain Hindsight. On hindsight, everything is a lot easier. So if you look at what we do as a fire service, if you look at what the information we have, what we need, and the authorities work together with, you come to realize that what we start to see now is that fire is not a single authority issue. If we pull up with our big red trucks in front of your house because it's on fire, we've missed a ton of opportunities to tell you about fire-safe living. And interestingly enough, although it's not a message a lot of people want to hear, fire discriminates. We basically see the prevalence of certain socio-ethnic backgrounds in our customer base, let's call it like that. And you also see that people who actually at some point have a fire had visits from other institutions as well. So by the time we show up, well, we could have known about it. We could have intervened before the fire went. Trust me, I love running into burning buildings. It might sound a bit strange, but I really love doing that. But by the time I do that, well, a lot of things have gone wrong in the process before. So we need to work better with other authorities. And that's what we started realizing 5 years ago. We need to work with other authorities in the city, in the state, for statistics, et cetera, et cetera. So that means that they should provide their data in a way that we can actually process it. Now, if we look at, for example, a very simple thing, and this is where it gets complex if we want to look at building data, because that is interesting for us. What type of building, how old, et cetera, et cetera. For a project for the Dutch Fire Service, and all the boxes are again Dutch, we looked at what information is available about buildings in various data sets. For the fire department to get a comprehensive view on a building, on the entity building, we need about 25 different data sets. 25 different data sets which tell us parameters of buildings which are interesting for us, either on the face of where we send out permits. If people want to start a new business, can you do that in a building? In prevention, are you actually following the rules? Or when there is a fire, how do we operate in this building? 25 different data sets. So you need to combine all these 25 different data sets to make a coherent picture and ask questions about that. And all these 25 different data sets are maintained and authored by external authorities. Cadastre, Chamber of Commerce, well, tons of different organizations. You actually want them to be connected so that you can ask questions when you're in the fire truck in this 4 minutes. So that this connection is not a cloud of, well, blue statements, but that it's actually connected up in your head. So one of the things we start doing, and this is where we're going to see a bit of duplication from the previous talk, is, well, okay, we're just going to drag in all the databases we can find about these buildings. We're just going to build a data warehouse. And I just made this data up, so there might be some issues with that. But we have something about building where height, in the reference to a height record and the year when it was built and the square meters and the energy label, et cetera, et cetera. We got some building information, what type of businesses are in there, et cetera. The problem is you need, if you want to process this, you need specific domain knowledge to understand which columns and which tables are actually linked together. Probably everybody in this room has received an Excel sheet in an email which is full of numbers and cells, and you're like, I have no idea what this is about, right? You need a domain specialist to tell you that. So all the data we get, well, yeah, you have the data. Oh, good. Now be done with it. No, you need the domain knowledge behind it. Because, well, what you're looking at is specific fields for a specific question. But then you need to understand how these data all relates to only get that tiny bit of data that you need. So why not use this in a graph model where the directions and the relations are described in the model itself. And luckily, this is sort of the same picture that I saw in the previous presentation. And let's put your eyes on it, and then we end up with a knowledge graph. And I think this afternoon we have plenty of time, if you want to get more in-depth of what the technology actually can do for you, in the knowledge graph form, that we can explain that. One of the important things, if you're going to do cross-authority connection and combinations of your databases, is that you have to talk about your terminology. And the terminology being used, if you're going to share and connect data, it's a nightmare, because it's something that most people don't want to do. We started a project in the Netherlands, Firebrary, authority set of fire department terms. Because the fire service, and that's a worldwide problem, we see that with all our customers, is completely filled with implicit terminology. My favorite example is in the Netherlands, we have schemes of determining the scale of the fire. It's pretty simple, large, small, or small, medium, large. Medium-sized fires are called out throughout the country 10 to 20 times a day. And it basically means that 2 fire engines were needed. When we had the National Congress of the Fire Service and we introduced the Firebrary, we asked 67 people, what is your definition of a mid-sized fire? And mind you, these were battalion chiefs. Those are the people with authority to actually declare a fire a mid-sized fire. How many answers did you think we got? 64. There were 3 people who sort of agreed before giving the answer and give the same answers. But now figure this. The Dutch Fire Service proudly published their yearly statistic last year. And they said, we have 200 mid-sized fires or something. I don't know the exact number. And I look at that, it's like, well, no, you didn't. Because nobody who actually signed up for the mid-sized fire actually agrees on what it means. So how can you publish a statistic? Let alone if other people start using it. And this is not an easy task to do. But if you're going to use knowledge graphs, if you're going to interconnect data systems, this is the point you need to work on. Terminology, before you start working on creating your complex data models. So we started working on connecting that. We got some terminology right. So we have now a knowledge graph with 16 of the 25 databases. And later this afternoon, I can give you a demo of how that really looks and works. So we now have all this data interconnected. So we're at this stage. Now the problem is, it's a lot. It's really a lot of information. And yes, it's connected and you can browse through it, but hey, I only have 4 minutes and I got other stuff to do. How are we going to use that? So would AI be able to help there? Another buzzword, I just throw it out there. Could really smart systems help us there? And I think knowledge graphs are ideally suited to be the base of where AI could actually really help moving us forward. But you have to make one big step. It's the environment where this is going to be used. So the environment I, as a firefighter, operate in. And you might at first think about, oh, it's hot, it's dangerous. And there's a more generic description of the environment we operate in. High risk, high consequence. Everybody probably gets that concept. If I run in a burning building and it goes all wrong, the consequences are going to be very grim. That's what fear is about. That's the trick question. Am I the only one in this room who does high risk, high consequence daily behavior? You're a mother. So I give you this. Driving in a tin can on a highway with 120 kilometers an hour is a high risk, high consequence action. So now comes the question, do you feel comfortable doing that? Probably yes, right? Maybe if you just got your driver's license, they're like, oh, you're still a bit shaky and wet-handed, but if you're 10 years down the road, driving on the highway is easy. So how can it be that we as humans are able to actually do these high-risk, high-consequence actions without any problems? Well, and you said you're a mother, so I have no clue how old the kid is, but at some point it's going to learn to walk. If you're a toddler and you cannot walk and you start walking, that's a high-risk, high-consequence environment. Every single step, the risk of falling over is really, really high. So how does it work that at some point they start running without issue? It's a method which we call recognition prime decision making. There's excellent papers about this. Recognition prime decision making helps us to make decisions based on previous experiences. For the toddler, it's like, well, if I put my foot too far forward, I don't make it, I fall over. If I put it behind me, it's not going to work. For you in your car, it's like, oh, I just hit the sidewalk, I have to make the turn a bit wider, and the next time you have no problems. That's how it works. Your brain works like that. We need that as humans to survive in a dangerous world when we were still hunting bears, etc. There is a really scary side effect of that. I was in here. It's like 13 years ago. I literally was in here at the moment of the fire. We came out, seriously beaten, black, but uninjured. We fought the fire. We were able to contain it to that one compartment, and we walked out, and we felt like badass firefighters. It's like, this is why I joined this department. This is what I need to do. This is my purpose of living. Over the years, I listened very carefully to what I've learned at the academy. Over the years, I started to understand fire behavior, and there is a complete research field on fire. And I started to realize, it's like, I was not a badass firefighter in there. I was damn lucky. I just entered from the right side of the building so that I had sort of the wind in the back while fighting this fire. Would we have entered from this side, which is not possible? If the wind direction would be different, we would have been fried. I probably would not be standing here without serious burn marks. Recognition prime decision making makes it very hard for a human to understand the difference between skill and luck. Between skill and luck. You probably drove on the highway and you saw something almost go wrong, and it's like, ooh, he was lucky. There's a fair chance the driver was like, I'm a very skilled driver. No, I've managed that. So if you think that is the way we process and you want to support firefighters in helping them to be safer, would actually having some earplug that tell you every step of the way help? Would that assist you with driving? Probably not, because I'm a skilled driver. I don't need that. I'll just throw it away. So we have to look at when things go wrong. So if you go over line of duty death reports and near miss reports all over the world, you'll find your clues. This is 4 years ago. At the foreground, you see firefighters pretty beat up. Their clothes are black, and on the rear, on the building, you can see it's completely scorched. And if you look closely in the look at their eye, they literally did not think they'd make it out of there. They escaped death. At least that's how they felt. They crawled out the window on the last moment because they could find it, but they really said goodbye to each other while they were in there. You can see the look in the eye. What the hell happened? Because the interesting thing is that apartment they were in is only 70 square meters, and the whole city is filled with the same apartments. I fought like probably 20 fires in apartments like that, and these guys got trapped in there. So what is the sort of overarching problem we see and reports we see? We did not expect that. We did not expect that the fire behaved like that. We did not expect there was a basement. We did not expect the building was that big. We did not expect that the floor would cave in. It's the same sentence. We did not expect. We did not expect. So my idea right now is, could we use knowledge graphs personalized to the firefighters that go in there to actually help them say, well, you might think you'll see this, but you're running into something unexpected. Because I think that would be sort of the next step. It's not operating, but we're working on it, and we got some really minimal results that actually show us that it can be done. We're not using it operationally, it's sort of a mental thing. So we need to prepare our firefighters for the unexpected. And that's the interesting part. It's the first thing I've learned. You never have fire with normal people. That put me in a mode. For every single fire I went into the first couple of weeks, I might meet someone who's not normal. And trust me, I did. I met people who collected 600 vacuum cleaners in their apartment. I met people who burned their kitchen down while sitting in the living room because they were going to be picked up by their mothership, maybe from the planet you refer to, etc., etc. So I learned in the very first stages where we need to go if we want to build AI systems on top of knowledge graphs. So how's my fear? At least I have an interesting audience right now where 12 years ago when I started with this, people were like, huh, what? People understand it. The technology to actually get rid of this fear is out there, and we just need the smart minds to actually go and do it. So I'll be around for the Knowledge Graph Forum, so if you have any questions, you want to see some of this stuff in action, just show up. Thank you.
Woo.
Okay, time-wise?
Go ahead, yes.
Yeah.
Wow. Okay, that was very insightful, and I hope it works out, because isn't the ideal case that you won't even have to go fight fire anymore because you expect everything?
That will never happen. So prediction is something from a how do you say that? From a scientific point of view, really predicting. So ringing at your door is like, well, I wouldn't fry your meat tonight because it will catch fire. That will never happen.
It's like Minority Report.
Minority Report. I don't believe in that. I think there is a lot of scientific sort of underground. Well, that's not going to work. We can see that certain behavior helps. That charging your phone behind your bed is a really bad idea. Having your laptop, your iBook, the MacBook Pros, for example, don't put them on a soft surface because, well, we see that in the statistics, basic statistic analysis. And then the other part is that there's nothing you can do about stupidity. I mean, barbecuing in the middle of the winter in your living room, there is no information campaign we can actually prevent people from doing that.
Well, Bart, I hope we don't have stupid questions out of the audience. We'll see. Are there any questions in the audience for Bart?
There's only stupid answers.
There actually are no stupid questions.
Yeah.
Und Sie können auch auf Deutsch fragen, weil Bart versteht auch Deutsch.
So I will try it in English, but there's one thing I don't know in English. You talked about getting the data, and for me, your whole talk sounded like you are fighting, that's the English word I don't know, Kampf gegen Windmühlen.
Yeah, I get that.
For 10 years. And I think the problem is that you simply do not get the data. For example, the parking houses, they simply don't want to offer you the data. Or so how do you feel? What's the actual problem?
It's partly. So there's a lot of data out there which is available. So when I started this whole quest, we didn't have it, and now you see there's a lot of data available. Interestingly enough, with the park houses, is more a standardization issue. It's like so people say, well, you can get it. Here's an Excel sheet. You can download this Excel sheet every 5 minutes, stuff like that. So can we come up with methods of standardizing access to that kind of stuff? That is more of a problem. It's more the scalability of these specific use cases, but the building information, the Chamber of Commerce, we have direct access to their systems right now. So that has dramatically improved, absolutely. So I didn't want to sound depressed, though.
Do you notice like the trend of going towards open government data within the last 10 years, that it has become, an issue for government agencies to release their data?
Absolutely, and I think there has been a sort of a wave. The first wave is that people say, oh yeah, we need to do open data, and I call that sort of the over the hedge principle. Like, oh, we have the open data, here you have it, and be done with it. And what you're actually looking at is data quality, the provenance, where does the data come from, the updates, regular updates. And that is where you see government agencies struggling. Okay, if we need to do the regular updates, that needs infrastructure, et cetera, et cetera. Okay. So that is sort of the second wave, what you see happening right now.
But there's movement.
Absolutely, absolutely, yes, absolutely.
Any more questions?
Hi, here. We've got the Daniel Kahneman sort of thinking fast, thinking slow, and heuristics and things like that. And what I see is that people are being encouraged to understand what their sort of natural thinking fast situations are. For example, when they fall into freezing cold water, people are now being told, look, relax, get your breathing under control, learn to float, and things like that, because it's the panic response that causes the drowning. So have you thought about taking a look at the physiological situation of the firefighters and feeding that back to them, so that what they can do is recognize when they're entering one of these thinking fast situations where their response might be inappropriate for the circumstances that they're in?
Absolutely. I only had 20 minutes, so... No, we actually have a program in Amsterdam. After this fire you saw, we started a program which is Stop and Think. And that's not sort of stop and have a conversation what we're going to do, but sort of stomach breathing, as we called it in Dutch. And then, okay, what is the next step? Am I seeing what I see? Am I going to do what I think I'm going to do, etc.? So yes, we absolutely work on that. And I think that would be a brilliant entry point for AI agents who can actually help us with, hey, this is not what you expect, be aware, sort of.
Maybe last question. I look at the time.
Can you describe what is currently state of art of technology? So what is really working at the moment? What you can do? How can you impress us as a crowd with things you do in the fire truck while you're driving to the fire?
So one of my favorite examples is, I don't think I can show it, but what we're using for one fire department is using the knowledge graph to actually get information from a system which is not directly connected, and that's child daycare facilities. The amount of places child daycare facilities have in the Netherlands is a separate data set which is vaguely connected to addresses and stuff like that. And we use the knowledge graph to completely map that. And I can demo that, how that works from a knowledge graph perspective later today, if you're interested in seeing that. So that if you go to a child daycare facility, you actually see it's this specific size. That is stuff we could not do before.
Okay, well, thank you very much, Bart. We also have the badge of honor for you.
Perfect.
It also lights up, so you can maybe wear it on your next assignment as a firefighter as a lucky charm. I hope it will save your life.
Excellent, thank you so much.
Thank you, Bart.